We have a Fresnel biprism and the source is kept at a distance A and the screen is at a distance B. The angle of the prism, let's say, is A. We need to find the wavelength if fringe width is given. Now the angle here is given in minutes. So we must know this basic conversion that 1 degree has 60 minutes. And each minute has 60 seconds. So 1 degree will have 3600 seconds. So here it is given as 20 minutes. So this angle theta is 1/3 of a degree. It's quite small. So this is a very small angled prism and we have a source and a screen. Interference will happen at the screen. We need to find the wavelength of the light if fringe width is given. So first thing, we know that because of these two prisms, the light will be bent in different directions, and because of that, interference will be produced. So at what angle those lights will be refracted, let's find that out first. So image of an axial object by a thin prism. So let's take the top half of the prism for convenience. So we have this prism and we have an object here. So now we know that for a small angle prism, deviation is constant and its value is mu minus 1 into A. So it doesn't matter what is the direction of your incident ray, the deviation is always constant and it is delta. So for convenience, let's take two lines, one which is parallel and one which is at an angle delta. So we are taking these two rays so we can easily see what the deviation will be. So for the parallel ray, or you can say it is just above where the prism starts, so that almost parallel ray will be deviated at an angle delta. And the ray which is going at an angle delta will deviate through delta, so it will become parallel. So if you extend these two rays, you will see that image will be formed here. And now we want to know what is the height of the image. So because this angle is delta, this is equal and opposite angle, this is also delta. So we can see tan delta is height upon A. So in this triangle IOP, tan delta is h upon A, which gives h is equal to A tan delta. And because delta is very small, equivalent to A delta, and delta is mu minus 1 into A. So this is the height of the image due to this object because of half the prism. Now we have two halves of the prism. So because of the top half, image will be formed here, and because of the bottom half, image will form here. So now we can directly, so we have basically the two slits now. Because of that, the interference is forming here. So we know the formula of fringe width, which is lambda into capital D by D. Capital D is the distance between the slits and the screen. So this becomes lambda into A plus B by D, which is 2h. So h and h, 2h. And the value of h we know is this. We'll just put that value of h here. So from here we get the value of lambda is equal to this, our answer.